Now, also part of chapter 3, we have another topic talks about exception handling. In this section, we like to show you how to take advantage of a standard exception handling routine and take advantage of it within the programming concept. A structured exception handling basically gives you a standard mechanism in order to throw exception throughout the program or capture the existing exception that will be generated by either a component or by operating system, and you can take advantage of it. There are some disadvantages of unstructured error handling that we had in VB6. If you remember, on VB6 you could either resume existing line of code or perhaps go and resume the next line or jump into a specific handler. That wasn't a great technique, obviously, because first of all, it wasn't a standard. Second of all, by changing the syntax of the code, you would have jumped to a wrong location, perhaps. So the code was difficult to read, debug, and maintain, and you could easily overlook some errors. The advantages of a structured exception handling is, first of all, it's supported by all languages in .NET, allows you to create protected blocks of code, and allows filtering of exceptions similar to the select cases statement. And of course, you could manipulate and maintain the code a lot better. You could also have nested handling, means within an exception you could go and basically nest that and control the execution a lot better. The code was easier to read, debug, and maintain. So now let's take a look at some of this demonstration in here. You have a try-catch block. As you see, you start the code by placing your code within a try-catch block, and by going through the statement in here, if there was any syntax was causing any exception, you would have catched it, part of the catch block. And if you couldn't catch it, basically operating system would have catched it for you. There's a finally block which automatically will run no matter what, even though you don't have any exception. It will automatically run it anyways. So whether or not you have an exception, you run the finally block. So let's pay attention to this demonstration in here. If I switch back in here, what I like to do, just go ahead and place a couple of other, let's say, controls in here, such as text box. I have text box 1 and text box 2. You can actually get rid of the value of them in order to make it a better demonstration. I like to add another button in here, and let's go and say divide. Now, what I like to do, I like to get the value of these two and divide them by each other. So let's go here, part of divide. I like to go and declare a variable, for example, result, result, for example, as, for example, integer, just for the sake of discussion. I like to go and specify result without using any exception handling to be equal to textbox1.text, basically divided by textbox2.text. As you see, I'm not using any conversion environment. Let's go see what's going to happen. If I launch this specific application, as you see, the form appears, and if I put, for example, 5 divided by 2, it actually, clicking on divide, let's see, I have not shown any message box, so let's go back in here and show the result into a message box at least, so we could see what's going on. Inside of the message box, if I go with result, now launch this again. As you see, the implicit conversion will occur and automatically shows the value. However, this is not the actual value, as you know. Since I'm choosing integer, it's not showing the actual value. Let's go and change the data type correctly, and instead of integer, let's go with double. So in this demonstration, you see choosing the right data type is important as well. Let's go and launch this, and launch this again and say 5.2, and as you see now, it shows a double value for me. Now, in this scenario, if I don't have an exception handling, which I don't have it at the moment, see what's going to happen if I put 0 for the second text box. If I go with 5 and 0 instead of 2, it gives me the infinity exception handling automatically. So since I'm doing the implicit conversion, Microsoft automatically provides me the exception handling for me. So I don't have to be worried about that. However, I could go with double and parse the information and basically convert the type before I do the arithmetic operation in there. Now let's see what's going to happen. I'm doing explicit conversion, 5 and 0, And as you see, automatically the exception handling will appear. The reason is being I'm using the common data type systems, which the exception handling automatically is being provided. However, if you wanted to go and specify your own exception handling routine, you could basically use the try catch block and just copy paste the line of code in there within the try, and if an exception occurs, you could basically show that within a message box. In this scenario, I'm using like ERR as a sort of exception class, and here all I like to do, show a message box and show the message that will appear and convert that message into a string and show it within a message box. So in this scenario, I'm trying to do something. If an exception occurs, I like to show that error within the message box in here. Let's go launch this, and now as you see, if I go with 5 and 0, it actually gives me the same thing. So as you see, you have automatic exception handling part of the common data type system. So whether or not you use this is basically being protected for you. You also have the finally block, which runs no matter what. I can put done. And as you see, even the exception occurs or not, the finally block will run. So I like to demonstrate that as well. 5 and 23, for example, or 2, that gives me this, and then finally done. If in the case of exception, it also shows done. So the finally would run no matter what. So part of this demonstration, I already showed you how to work with try, catch, and finally block. And of course here, this is another example. You're declaring a couple of variables, and as you see, basically the same scenario is being demonstrated here in this slide. I've already demonstrated that for you. There is a exception class, as you saw, provides message property, which is telling you why the exception was thrown. The source property, it tells you the name of the application or object that got generated or generate the exception. You got the stack trace, which is showing you the exception history. It gives you the inner exception just in case for nested exception. Help link, just in case if you have a URL or a link to a help file, sometimes you can throw an exception and provide the documentation for that. And then finally, to a string method, which converts the result of an exception into a string. You could filter the exception by having more than one catch block, as you see. You could be specific. Instead of having like a pure C exception class, you could be very specific about that exception and get more detailed information about it. In this scenario, you could probably see if it's divided by 0, you could show a specific message. If it is overflow exception, you could show that a specific message. If you can use the old ERR object in VB6, if you remember, you could actually just check for the error number just in case. And of course, you could capture an exception and throw your own kind of exception. Just in case if the exception doesn't make sense to the user, you could capture that and throw a new exception that makes more sense to the user, end user. In order to do that, you could throw an exception by using the throw keyword. You could throw a new exception and specify the error message that way. And basically, I can demonstrate that for you. If I go back in here, in the case of an exception, instead of showing the error message, as you see, I can throw a new exception and specify the message. This is my custom, for example, error. So if I launch this now, in the case of an error, not only I show the original message, but also I throw my own exception. So pay attention to this. This is the standard message. This is done, finally block. As you see, I have already handled that. Let's go see why I didn't throw that exception. Let's go actually provide that line outside of the catch, because when I throw, then I have to be able to catch it. So let's go and bring the throw up a little bit and have the exception to be handled gracefully. 5 and 0. As you see, this is infinity, and now this is my custom error message that I've thrown. The reason at first it didn't work because the throw was inside of the catch already, and there was no other block in order to go and basically catch my exception. So I've already demonstrated how to work with the structured exception handling, and of course that will allow you to go and perform the second lab, in which allows you to go and implement exception handling routine within your code.